Hello everyone and welcome back to the new video. So in this particular video, we are going to manage secrets inside of the Kubernetes with the help of Vault as well as external secrets operator. We are going to understand what is a cluster secret store, what is an external secret. We are also going to understand the flow of secrets from Vault into the Kubernetes workloads. So overall, we are going to understand almost everything related to the managing secrets with Vault, right? We are also going to do the hands-on part in this particular video. So you are not going to miss out anything if you watch this video till the end, okay? So stay with me till the end and this is definitely going to help you out, okay? So without wasting any time, let's get started. So first, let's try to understand what is the problem. So why do we need Vault when we already have secrets in Kubernetes, right? So let's try to understand the problem with managing secrets inside of the Kubernetes itself. Now, in most of the GitOps approaches, we store our manifests inside of the Git, right? And with them, if we try to store the secrets as well inside of the Git, then it is going to cause a security breach because it is not advisable to store the sensitive data inside of the version control. Because even if we delete or remove those secrets, still it is stored inside of the previous commit. So it is not advisable to store secrets in Git, right? So that is one reason. The other one is that manual rotation. You cannot manually update credentials into multiple services and namespaces that you have inside of your Kubernetes cluster. It's okay if you have got one or two such secret files and you just need to update them, right? But in case of production systems, you don't have just one or two, you have hundreds and thousands of such secrets which you would want to maintain. And it is practically not possible and scalable to kind of update each one of them separately and manually, right? So in order to avoid this, we don't prefer managing secrets in Kubernetes, okay? Now the last one is that no audit trail. That is, if your secrets are getting accessed by someone, there are no logs. There is no such record that who is updating the secret, who is accessing the secret. So if there is any issue, you won't be able to debug it. So this is another reason why we should not go for secrets in Kubernetes, right? This is the reason we should go for HashiCorp Vault or let's say AWS Secrets Manager. In this video, we are going to just talk about the Vault, but if you want me to make a video around AWS Secrets Manager as well, do let me know in the comment section, okay? Now let's move to the next one. So basically, what is a HashiCorp Vault? HashiCorp Vault is a centralized secret storage with encryption at rest as well as in transit, which means that it is nothing but a centralized place where you can store your secrets, which will be in the encrypted form in their resting position as well as in transit. Okay, so they are totally secure. Then they also provide dynamic secrets. That is, they can help us generate secrets on demand as well. Okay, and they can also auto expire these generated credentials. So this is another feature which is provided by Vault to us. Okay, then there are also fine-grained ACL policies per service, team or namespace. So access is provided as per the service, team as well as namespace. So not anyone can access any secret, right? So this kind of fine-grained ACL policies is possible with the help of HashiCorp Vault. So there are multiple authentication methods, like we can go with service accounts, then we have app role, then we have LDAP and AWS IAM. In this particular video, we are just going to discuss two ways, okay? That is service account as well as token reference, which we are going to discuss later. So wait till then. Full audit logging of every secret access is possible with the help of HashiCorp Vault. That is, all the logs related to the access or whatever policies that you have provided are available inside of your audit.log. Okay. Then we have got multiple secret engines as well. That is KV, that is key value V2. Okay. Then we have PKI, database, AWS, Azure, and many more. Okay. So you can create these secrets inside of the vault either with the help of a command line tool, that is Vault. So over here you can see few examples which I have provided. So this is done using the command CLI, right? It can be used to create the secrets inside of your vault, or you can also go for manual way. Okay, any way would be fine. No worries at all. Now let's try to understand the external secrets operator architecture. Now how does this actually work, right? So it is important to understand. So specifically, what is Vault used for? Just storing the secrets. But our pod now wants the secret, right? So in order to use this secret from Vault inside of the pod, we will be making use of ESO, that is external secrets operator. Okay. Now this external secrets operator is inside of your cluster. See, Vault is something that you can deploy on your cluster, or it can be outside your cluster as well. It is free to be anywhere, right? It doesn't have to be on the cluster. Whereas external secrets operator is present inside of your Kubernetes. It is nothing but a controller which is going to fetch the secrets from the HashiCorp Vault, pull them inside of the native Kubernetes secret, and then being available for the pod. Okay, so let's try to understand. So over here you can see the yellow section where we have secret backend for the HashiCorp Vault, where we have our secret. Now with the help of authentication, external secrets operator is going to pull the secrets, it is going to fetch the secrets, it is going to sync it to the native secret, and then this native secret will be mounted as environment or volume on your application pod. Okay, so this is the exact flow. You can take the screenshot of it, or if you want, I can share this PPT with you guys. If you want this, do comment as PPT in the comment section so that I can provide link inside of the description. Okay. Now the next thing is about ClusterSecretStore. Now what is a ClusterSecretStore? We have got Vault, we have got ESO. Now from where does this ClusterSecretStore come, right? So let's try to understand that. So ClusterSecretStore is a way of authenticating your ESO with the Vault. Okay, so we are going to connect the external secrets operator with your Vault with the help of ClusterSecretStore. So a cluster scope CRD that defines how ESO connects to your Vault. Okay, and unlike the secret store, now there are two terms, ClusterSecretStore as well as just the secret store. So there are two of them. So secret store is just scoped with the namespace, scoped limited to the namespace, whereas the ClusterSecretStore is applicable for the entire cluster. Okay, so that's the major difference between them. In the next slide, we are going to understand the difference in a more better way. Okay, so basically just keep in your mind that ClusterSecretStore is a way to connect your ESO to the vault. That's it. Okay, and what are properties or what are fields that over here we need to mention? So the foremost thing is the URL. Vault URL address is what you need to mention inside of the provider inside of the vault. Okay, so this is what you need to mention. Then you have got path, right? Path to your KV engine if you are creating a KV secret, right? And the version you need to mention, followed by, for the authentication purpose, you can go with a token secret ref where you will be providing the token. Okay, so within the auth section, you can also make use of service account. But here we are just going with a token secret reference as of now. Okay, because in the hands-on also we are going to just implement token secret ref. But if you want me to create a video around service account as well, do let me know. Now let's try to understand what is the difference between secret store as well as cluster secret store. I have already told you the scope of a secret store is namespace scoped, whereas the scope of the cluster secret store is cluster scoped, which means this particular secret store is limited to a particular namespace, whereas this one for the entire cluster. The use case is that when each team or namespace manages their own store, then in that case we make use of a secret store. And in case of cluster secret store, when a central platform team is the one who is managing one vault connection, then in that case you can go for the cluster secret store. Okay, only external secrets in the same namespace can reference to the secret store. The external secrets in any namespace can reference it. Okay, authentication using the service account must exist in the same namespace, whereas authentication with a service account must be explicitly declared in the spec section. So within the spec section itself, we need to define the namespace of the service account. Okay, so that is very much important and that's what you need to take care of. Then multi-tenant clusters where teams manage their own vault connection, SecretStore is the best thing that you need to use there. Okay, if the platform managed clusters where a central team owns the vault integration, then in that case you can go for the cluster secret store. So it is not that one thing is right and the other thing is wrong, where it depends on the use case and the situation of your teams. Okay, so it depends around that. Now there are two different ways of vault authentication. There are multiple ways actually, but we are just going to discuss about service account authentication as well as the vault token authentication. And within the hands-on, we are just going to implement the vault token one. Okay, let's try to understand this. So how does service account auth actually work? So ESO, that is our external secrets operator, has a Kubernetes service account. It takes that account's JWT token and sends it to the vault. Vault then calls the Kubernetes API to verify and issues a short-lived vault token. So just to remember, one thing you should understand that in here we are making use of a JWT token. Okay, and the vault then issues a short-lived vault token. So it is a short-lived one. It's not a long-term token that we are going to use, right? In case of service account, we have short-lived one, whereas in case of token secret ref, it is long-lived one. Okay. So in case of vault token, a long-lived vault token is generated manually and is stored in a Kubernetes secret. Okay. And then the cluster secret store references it via token secret ref. So ESO uses it directly to call the Vault API. Okay. So we have got a long-lived token, and this token is stored inside of the Kubernetes secrets, and with the help of that token we are going to authenticate with the vault. Simple. In case of service account auth, we have a short-lived token and it uses JWT, whereas in case of vault token, it is a long-lived one and we make use of Kubernetes secrets to store, and then the same one will be using to authenticate to the vault. Simple, crisp. Now, each one of them have their own pros as well as cons. Okay, so these, that is the service account tokens, are not long lived, because of which they are more secure. Then native Kubernetes identity, no manual token management is involved in this. Everything is done by the API management. Then we have got vault role bound to specific service account name as well as namespace. So this is what happens inside of the service account. Now let's talk about the vault token. It is a simple setup. No vault auth backend configuration is needed in here. It just works in air-gapped or restricted environments. There is no dependency on Vault reaching the Kubernetes API. So I said the same thing, right? So API is handling everything in case of service account. Whereas in case of Vault tokens, we don't involve the API. So it is a simpler approach. Okay. Now let's try to understand cons of both of them. So it requires Vault Kubernetes auth backend enabled. So this is another thing you need to consider, right? And it needs Vault to reach Kubernetes API server for the token review. Okay. Whereas in case of Vault token, it is a long-lived token and we ourselves have to rotate it manually. Okay. Token stored as a Kubernetes secret. Okay. So requires tight RBAC because again we are storing the token in the form of a secret, right? So anyone can access it and misuse it. So this is something that we need to manage. So generally in case of production systems, people go with a service account authentication. Okay, because though it is a short-lived token and you need to have your Vault backend for the Kubernetes enabled, but still it is a better approach because you don't need to manage the native Kubernetes secret over here. Whereas in case of Vault token, you have to manage the native Kubernetes secret, which is again not a very good thing to store the token. So yeah, so these are the two ways. For Vault token, we generally go when we are testing something, and in production systems, we go with the service account. Now let's try to understand the external secrets. So what do we need first is we need a vault. Next we need an ESO operator. Then we need a cluster secret store for authentication purpose. Once the authentication is done, we need to pull the secrets with the help of external secrets. So the sequence goes like vault, ESO, cluster secret store and external secrets. So now we are going to talk about external secrets which help us in mapping the vault paths to the Kubernetes secrets. Now let's understand it. So a namespace scoped CRD. Now this one, that is external secret, is namespace scoped and which specifies which vault secrets to fetch and how to map them into the Kubernetes secret object. Okay, so the definition, everything is present in here. If you just observe the YAML file, you will get everything. So what is it? First, we define the API version, then we define the kind, then metadata, where we define name as well as namespace, followed by the spec. Now, inside of the spec, we define refresh interval, which is of 1 hour. So, over here it is 1 hour, you can change it. So, what is a refresh interval? So, refresh interval is nothing but how often the ESO will sync. Okay, so there might be some changes, right? If there is a change inside of the vault, to pull that same change inside of the external secret, we need to keep on checking. So how often should we check? After every 1 hour. So that's what we mention inside of here, that is refresh interval. Now the next thing is about SecretStore reference. Now SecretStore reference is what we define for the ClusterSecretStore. So which ClusterSecretStore should the ESO use in order to authenticate to my vault? So that cluster is what I define inside of the SecretStore reference. Then I have the target. Target is the name of the secret, the native Kubernetes secret, okay, which I want to create. Then we have got data. Within data, we define the secret key. Now, the name of my secret that I want to store is something that is DB password. And then what is the remote reference of it? That I define inside remote ref with key as the path. So this is the path to my key which is stored inside of the vault. So this is the path of the key inside of the vault. Okay, it is not something related to the secrets or something within the Kubernetes cluster. No, it is something related to the vault. And then property, that is within this path, which property should I pick up for this particular secret key. That's all. Okay. So as simple as that, external secrets are very easy to write. Okay. So once you master it, it's gonna be magical for you. So let's try to understand the end-to-end secret flow. So basically developer creates an external secret manifest referencing the ClusterSecretStore as well as the vault path, right? So it first writes the external secret. Once you write it, ESO reconciles. So ESO is nothing but a controller. So it detects the external secret and starts the sync process. Its work is to bring the secrets from the vault into the native Kubernetes secrets, right? So it syncs it. Next thing what ESO does is, it first tries to authenticate. And for authentication, it might go with service account. If service account authentication is defined, ESO will authenticate via that particular token. Otherwise, it will go for the vault token. Simple. Once the authentication is done, it will then go for fetching the secret values. Okay. So ESO calls get. So it, with the help of get kind of API request, it is going to fetch the secrets at that particular path using the vault token. Then vault checks the ACL policy. Okay. Now once this is done, once the secret value is fetched, it is then going to create the KTS secret. It creates or updates a native Kubernetes secret object with the fetched values. Once that is done, pod consumes the secret. Now, application pod mounts the KTS secret as env variables or volumes. No direct vault access is needed in here. Okay. So this is how the end-to-end secret flow actually works inside when we are making use of ESO operator for managing secrets inside of the vault. So this is amazing, right? Then the last thing is about the summary over here. So HashiCorp Vault is nothing but a central encrypted audited secrets backend with dynamic secrets and fine-grained ACL policies. Okay. Then we have ClusterSecretStore, which is used for connecting to your vault, right, across the entire cluster for all the namespaces, and just the secret store is for specific namespaces. Then we have got external secret, which is where we define that which cluster secret store should we refer to, then what should be the name of the secret that we are going to create out of it. So all of these details are present inside of the external secret, right? And then we have got ESO controller, that is the one which reconciles the external secrets continuously, authenticates, fetches, as well as syncs secrets on a schedule. So this was all about the concept of making use of Vault as well as ESO for fetching and managing the secrets in Kubernetes. Okay. So now let's go to our cluster and actually implement this hands-on to understand it in a much better way. Okay. So let's go. So yes, this is the repository which we are going to refer for our hands-on session. Okay. And what we are going to do in this particular practical session is that we are going to deploy a vault on our K8s cluster itself. Okay. And once that is done, what we are going to do is we are then going to deploy the application as well as the database. And the connection between them will be done using the secrets which are stored on our vault. Okay. So this is the actual thing that's what we are going to implement. So over here we have the application files. So this is the server.js and this is the Docker file. So with this Docker file, I built a Docker image already and I have pushed it onto a Docker Hub repository. You can also do it the same way. Okay. And if you don't know, you can refer my previous videos where I have already done it multiple times. Okay. Now, within the K8s, we have got all the manifest files that we are going to use in this particular session. So, the first thing that we need to create is a namespace.yaml. Okay, after the Vault deployment, we will be creating the namespace. So, this is the namespace where we are deploying our application as well as the Postgres database. Then these three files are very, very important because with the help of these files, we will be able to kind of connect our cluster with the vault. Okay. So this is ClusterSecretStore file, right? Over here you can see I have defined all of it. The most important configuration part is within the spec over here. Okay. And this is the provider where we have defined vault. The server over here is the URL of your vault. Now, since this vault is deployed already on your cluster, the path to your service of the vault has been provided in here. Okay. And this is the fully qualified domain name of our service. Okay. Then we have the path. So this is the path where we will be storing all of our secrets. Then we have the version, which is v2, followed by auth, where we define the token secret ref. Now, we will first be creating the secret, okay, named as vault-token, and that secret will be referred in here. Okay. Next thing is about fetching the secrets with the help of external secrets. Okay. Now in here you can see the external secret, and I will be fetching the secrets for the database as well as for the Docker login credentials. Since we have stored our application image on the Docker Hub, we require to pull those. And in order to pull those images, we need the Docker creds. So for that, we have created the external secret. Then we have defined the secret store reference. Okay. So these credentials will also be stored inside our vault. Then we have defined the target over here. So target over here is nothing but the type. Since the secret type should be of Docker config, right? That is the reason these things we need to mention. Okay. So the foremost thing is about name. What should be the name of your secret? Followed by the creation policy. So it is the owner. Then we have template where we have defined that it should be of type Docker config JSON. And within data, we define the Docker config JSON, which has the details of Docker username, Docker password, as well as the URL of our Docker Hub. And the auth will happen with this. And from where is it getting the username as well as password? It is from here. That is from the vault itself. So within the Docker creds key, we will be having this particular property, and this is what we want to fetch in here. Okay. Similarly for the Docker password as well. Okay. Now let's go to the external secret. Now these are for the database credentials. Okay. Now the similar structure will be available right here. The target is what differs because the name of the secret is my app secrets and the creation policy is owner again. And here in the data that we have defined is a secret key. So it should be pulled inside of the secret with the secret key as DB username. And the remote reference that it should be referring is this particular path within the vault. And the property is this particular key which is be available inside of the vault itself. So these things is what we need to consider. Then the most important part is application. So this is our deployment file as well as the service file for our application. So you can go through this and try to understand. I have already explained this in previous videos. Okay. Then the next thing is about Postgres. Now in here I have defined the config map. Then the persistent volume claim, which I will be considering. Okay. And then we have the stateful set as well for our database. And yes, so all of these things again you can go through it. And lastly we have the service over here. Okay. So that's all about it. So what we are going to do is we are going to refer this readme file in here. Okay. So these readme file has got all of the instructions that we need to follow, and one by one we are going to follow this. So basically we have already got this particular cluster already created. So what we need to do here is first go and kind of install the EKSCTL. Okay. So that's something that we'll have to, sorry, I'm really sorry. Yeah. So I'll just be pasting it right here. And let's see if the EKSCTL has been installed. Yes, it is. And I have one get helm.sh, which is going to install Helm over here. Okay, and kubectl is something that is already present, so I don't need to install it. So that's all. And if you can see over here, the EKS cluster has already been created, so we are going to use this. Okay. Now the foremost thing that we'll be doing is to install the vault on the cluster. So this, with the help of this particular command, we'll be able to kind of install it. Okay, so it is done. So let's do kubectl get all. And over here you can see the pod vault -0 is in the container creating state, and you have got the services related to the vault, right? And if you want to access this service, what you can do is you can just create a load balancer out of it. It is of type cluster IP, right? So let's do that. kubectl edit svc/vault. Okay, and let me edit it. So you can see the cluster IP over here as a type. So just try to update it to load balancer. So this has been edited, and now if I check kubectl get all, you will see that this type has been changed to load balancer. And if I try to access this, I will be able to access the vault service. And this is running on port 8200. This might take some time. Yes, now it is getting loaded. So you can see that you will be able to sign into the vault. If I enter root over here, I will be able to sign in. Okay. So root is the default token for our vault over here. Okay. So this is what we use. Now the next thing that we need to follow is we will also have to install the external secrets controller, right? ESO controller also needs to be installed. So what we'll do is we'll just use Helm once again to install it. And it is deployed inside of the external secrets namespace. Okay. If I do kubectl get all -n external secrets, I will be able to view all the ESO controller related. You can see this external secrets cert controller over here, right? So this is very much important because this is the one that is actually going to play a vital role in fetching the secrets, right? So it must be installed. Now, since we are dealing with the persistent volumes, we will be making use of EBS CSI over here. So I will be kind of attaching a role policy to it. So first I need to check what is the name of the role. So what I'll do is I'll first paste it over here. Okay. And just change the name of the node instance role name. Let me go to EC2. Now within EC2, and over here within security, I will be able to get the name of the role. So this is the role, adding this one over here we are using, and paste it, enter. And this is done. Now the next thing that I'll be doing is to kind of install the EBS CSI controller. And this is also done. Okay. So I do kubectl get all. We can see the vault resources over here. For the external secrets, I can check them inside of the external secrets namespace, right? And then for the EBS CSI, let us check them inside of the kube system. So you can see EBS CSI controller has been installed. Okay, can check all of these and they are up and running. So we are done with this. Now the most important thing is to create a secret. I said that, right? So if we are going to follow the approach for the vault token, then in that case we need to go with the creation of a native Kubernetes secret. So this vault token has been created. Now this vault token will be used by your ClusterSecretStore in order to kind of fetch the secrets, right? So this is the exact sequence with which you should, apply the changes. So the first thing that I'm going to do is kind of cloning. So I have already cloned it. So let's go inside of this particular folder of get vault. But before that, before all of this, we first need to go inside of the vault. Okay. So within the secret engines, I would be kind of deleting this particular engine and instead I will be creating a new KV kind, and then I'll go for the paths since I have defined apps as my path, right? So I'll show you where I have defined it. So inside of the cluster secret over here, the path which I have mentioned is apps. So I need to define apps as my path over here. I will keep the number of versions as 3 and enable the engine. Now I will be creating the secrets. Okay. Now for the secret of this one, that is the database secrets, I have defined a path that is my app, right? So that is why I defined my app over here. And within this, I will be defining the DB user name. Okay. So the DB user name, I can define anything. Okay. I'll just click add. Then for the DB password, I will be defining the password for my Postgres, right? I'll be adding this and save. Okay. So we have got one secret configuration over here. I will be creating another one for the Docker creds, right? So for that we have defined another path. So what's the path here? That's just the Docker creds, right? So I will be defining the same thing over here as Docker creds. And within this, the key name will be Docker user name. Okay. Then I'll have to pass the Docker password. Okay. And add and save them. So within apps itself, now you have got my app as well as Docker creds. So you can either provide the entire path or you can just provide the name of this as well. Okay. but it is better to always provide the entire path. So I'll just kind of edit it. Okay. I'll just try to mention it as app slash, and here as well app slash, and commit those changes in here. Okay. And the same thing I'll try to get pull from here. Okay. So that's it. So now we are ready with the credentials already created on our vault, right? Now what we'll do is we are one by one going to apply the YAML files. So let's go inside of my KTS folder, and in here I have got all of this. First thing, I will be creating the namespace. Okay, apply -f namespace dot YAML. Okay, now let's check if this particular namespace has been created or not. So yes, you can see this namespace has been created. Now the next thing is to apply the cluster secret. We have already created the Kubernetes secret for Vault token. Now we are just going to create the ClusterSecretStore. Apply -f cluster secret.yaml. So this one has also been created. So let's check the status of it. ClusterSecretStore -n my app. Okay. So now over here you can see that this ClusterSecretStore has been created, which is valid, and it has the capabilities of read and write. You can modify these capabilities. Okay. So that can also be done. But in order to keep this video a bit simple and beginner friendly, I have just, kept the things minimal. So we are done with the creation of ClusterSecretStore. Now the next thing we are going to create is creation of these secrets. So how we'll do that? Let's go Kubernetes kubectl apply -f external secret dot YAML. So this has been also created. So let's check kubectl get external secrets -n my app. So yes, and over here you can see the secret has been synced. If it was not able to, pull the secret, then it would have said secret sync failed. Okay. Since it has successfully pulled or fetched the secret, it is showing me the secret synced over here. Okay. Now I will be going for kubectl apply -f external secrets -docker.yaml. Okay. Let's do kubectl get es. Okay, I already have this command. So yes, this one is also synced. Now, since both of these are synced, we must have a native Kubernetes secret already created. So let's go and check it out. kubectl get secrets -n my app. So now you can see these secrets have been created right within the my app namespace. Okay. Now the next thing is to create the Postgres first. Let it bound to the PVC, and then we will be creating our deployment for backend application. Okay. So kubectl apply -f postgres.yaml. Okay. So there is some error over here. Let's try to find out what's the error. So if I go inside of it, it is app/v1, right? Then what's wrong with it? Okay, for time being, without considering it as a stateful set, let's go as a deployment. Okay. I don't want to increase the complexities. What I'll do is I'll sync the changes. Okay. And now can apply it. Sorry. KTS. Yes. So now it has been created. Okay. Now if I check for the get deployments -n my app, you will be able to see the Postgres over here. Okay. And if you want to check whether the PVC has been created and is bound, we will be executing. So yes. So you can see that the PVC has been created and is bound to the storage class, right? And now if I check kubectl get all -n my app, so it is up and running and it is in a ready state. Okay, so everything is working fine. Cool. Now let's try to apply the backend application deployment app.yaml. So this is also created. Now let's check if all these are up and running. So this might take some time. Okay. Let's, keep this in the watch state. Get pods -n my app -w. And yes, so both of them are in the running state. Now let's check if the application, that is the backend application, was able to connect to our database. And it can only be able to connect to our database if the secrets are correct, right? So let's go kubectl get svc -n my app. Okay. So how are we going to do that? So first thing that I'll be doing is to kind of expose or port forward this particular service, and I will be port forwarding it to 3000 port number. Oops, sorry, I forgot to mention the namespace. Okay, so it is now forwarding to this. Now I can curl, right? So curl http localhost full at port 3000 slash, let's check whether it is in the running state or not. So the status is okay. And if I just curl it, it is giving me the message that the application is running, which means the application is also working fine, right? So this is the path which is going to tell me whether the application has got connected to my database or not. So if I enter it, and here you can see that the database is connected and the current time is this. So thus we are now able to connect our backend application to the database using the secrets which are stored inside of the vault, and we didn't store these secrets on our GitHub repository as well, right? So, this is how things work in production. So, everything is, all the secrets and credentials are stored inside of the vault, and they are just being pulled whenever they are required inside of a cluster. So, this is how interesting it is, and I hope that this video really provided value to all of you. And if you found this video really helpful, do make sure to like, share, and subscribe. It really helps me to make more such videos, right? So, thank you so much for staying till here.